school in the West Indian Ocean. This is the first time we're having it in this region.
Excited about this summer school, and I hope our students are going to learn a lot from us, but also it's also an opportunity for us to learn from the students.
My expectations for the week are to expand my interest in the fisheries sector, fisheries governance, as well as post-harvest that I can apply in my fieldwork as part of my master's research.
Welcome to Coes-Wio 2025 Mombasa, Kenya. Burudika nasi.
Welcome to Mombasa, Kenya!
I'm Brian Murenya Mojong from Kenya.
Leonardo Simati Nshiki from Tanzania.
I'm Ashil Duvesh Kalichon. I am from Mauritius and I'm in the group of climate change,
Physical and Chemical Oceanography group.
My group is small scale and mariculture. So today, in day 2, actually we had 2 trips. First trip we went to the Umoja Association group. Yes, so we learned a lot of things there. Yeah, including we found they are doing aquaculture fisheries. They are doing integrated aquaculture fisheries. They are also doing tilapia farming. The Oleochlomis niloticus, which have been taken from the Lake Victoria and being used in the marine water. So at first I didn't know if the fish from the Lake Victoria it may survive in saline water. So I was very interested with that idea.
We were able to learn about biogeochemistry and the stratification of the area, and it was really fun to
do you have your presentations there?
You can't hear me, right? Chemical processes to understand the biological
you have your presentation here?
Also to understand the
ecological survey data. Are you all here? Yes. You have your presentation.
First time that we are coming together as a summer school in Kemfree. So for the basis of time, allow me to ride on the previously established protocols because of time. This is Team Fisheries, and we are going to make a presentation. The team members are adequately represented there. And you know that Kenya is known for long distance running, but this presentation is going to take a relay form, where I'll be setting the pace and then hand over the baton to the next team player. So sit comfortably and enjoy the presentation. So just before I go to the presentation, allow me to quote 2 of my most famous marine biologists, Dr. Sylvia Elril. No water, no life, no blue, no green. And another very famous marine biologist, Dr. Robert Swan, Obi. The greatest danger to our planet is the belief that someone else are going to fix it. We have to all fix it instead of waiting for someone else to fix it. Because if you wait, nobody will fix it. So right away, I'll go to the presentation, small-scale fisheries, mariculture, and post-harvest management. So those are the group members that will be leading this presentation. So kindly move to the next slide. So basically, our assignment was to map the raw data along the habitat in terms of abundance and diversity. So from the data that we are working on, in terms of our habitat abundance, a total of 935 fish individuals were sampled from 85 species. This was recorded in different habitats, including coral reefs, mangroves, and seagrass areas. So seagrass and coral reefs habitat shows the greatest abundance at approximately 47%. You can see that representation there, having the combination of seagrass and corals having the highest number, followed by the coral reefs, the pelagic habitat and the seagrass, and coming in distance last is the lagoon. Because of time, I might not be able to go to the factors that may lead to this. That can be a discussion for another day. So coral reefs, in terms of abundance, they're at 36%. The pelagic zone contributed around 12%, and the seagrass habitat accounted for roughly 3%. So in the last one there, the lagoon had a mere paltry 1%. So we can proceed. So in terms of diversity, basically the species that are found within the habitats in terms of diverse are per habitat. So this can also be referred as species richness, how each habitat was rich in terms of the species numbers. The coral reefs habitat hosts the highest number in terms of species at 40%. And then if you combine the two, the seagrass ecosystem and the coral reefs combined, you have 36 species. So you can see that the coral reefs and the seagrass combined is giving up to almost 76%, the lion's share that were sampled. So pelagic contributed to roughly 34. So these are the mid-water, the tunas that are normally found in the pelagic waters. So seagrass alone, isolated, only contributed to 4. And this made me remember the words of my mentor, Professor Munga, when he talked about the connectivity in terms of the habitat. How do you relate the coral, the mangroves? So these habitats are interjoined twins. And in terms of conservation, we need to address collectively, because each on its own might not be able to be as productive. So the lagoon are the least represented, and I say that we might not be able to go into details. So as I finish, because of time, my parting shot, there is need in mitigating the threats posed to these critical habitats. The elephant in the room being global warming, a very serious threat to coral reefs, leading to coral bleaching, ocean acidification, greenhouse emission leading to global warming, sedimentation, and destructive fishing practice. Now, having said the piece, I have ably hand over the baton to the next team player who should be moving to the stage. And we have very good biodiversity. You remember that I'm Justice Wandati from Kenya Marine Fisheries, Kenya. My able sister here, Sulu from Tanzania, will take the baton. Thank you so much, my sister. Welcome.
Good afternoon, everyone. So for my part, I'll go directly to the seaweed farming, please. Okay, so the seaweed, as we all know, it's non-flowering plants which are usually found in the sea or oceans. So we have different species here which have different colors, usually which are found in East Africa are those with green, brown. We have sometimes red and blue-green, which are not very common. This is usually caused by the pigments, just like us humans who have different colors. They are white, brown, and black. So the same with the seaweed. Actually, seaweed is one of the most important habitat, and as a product which is now currently neglected in our Western Indian Oceans. So we currently have only 2 types of seaweeds or species which are farmed here in East Africa, which is a cottony and spinosum, whereby the cottony is less resistant and a delicate one, so it's not very advisable to farm it here in the East Africa due to our very low technology, but there are some countries who are performing it well. And the spinosum, which this is hard and resistant. So this is mostly farmed, although cottony gives more yield of the collagenum rather than the spinosum. Next slides, please. So before farming of the seaweed, we need to carefully select the site to ensure great productions. So it should be in a sandy or not a muddy area because of the anchors to resist against the disease and all that. Also, it should avoid freshwater intrusions because the freshwater might affect the seaweed and cause diseases such as ice disease, which is very common here in East Africa. And also we have to avoid areas with strong currents because the areas it might affect the seaweed because of the strong currents. Also, water level should be below the knee. As we all know, seaweed also always needs to be in water, so it should not be exposed to sunlight in a very long time. And also, when planting the seaweed, the pegs should be parallel to the shoreline to minimize the resistance against tidal waves. So when there's very strong waves, they might affect the seaweed. The method of seaweed farming, the most common used here in East Africa is off bottom, where the seaweed is suspended on the shallow water, but it does not touch the bottom of the sea, because if it touches there, it's likely to carry bacteria and destruct the seaweed. So usually the seaweed is supposed to farm at the low tides, because if it's very high tide, we can't be able to reach the areas where we want to put it. And in the next process, after choosing the site, the planting, we usually use, the most common used here is a tie-to-tie method, where we use pegs, ropes, and ties to plant the seaweed. Next slide, please. After 6 weeks, which is about 1.5 months, we're going to harvest the seaweed and dry it. The seaweed is very well mature after 6 weeks, and it's going to give a lot more collagen after 6 weeks. Less than that is contained a very little. So during the harvesting, we just take the ropes from the sea and take away the seaweed. And the ropes should be washed so as to reduce the epiphytes which have maybe attached in the ropes. Next. And after that, after harvesting, we dry the seaweed, and it usually takes 3 to 5 days to dry during the sunny days. And the seaweed should be dried in the shade. It should not be exposed towards sunlight, because the sunlight affects the nutrients in the seaweed. Next. After drying, it's a processing method where it's passed through different stages, where it's measured, washed, and there are different stages which is passing through, like the cutting, grinding, and finally to the fine powder. So it usually depends on what you want to make out of the seaweed. So if you want a fine powder, so yes, you can grind it to the last stage. Next. Okay, for the uses of seaweed, it is used to make soups, shampoos, food, vegetables, and salads. We actually saw this where we went at Kibuyuni. They have these products. And various red and brown seaweed are used to produce 3 hydrocolloids, which is agar, alginate, and carrageenan, and also commercial partners and manufacturers used in catering, pharmaceuticals, and cosmetic industries. Example, there's some toothpaste which are made of seaweed. Next. For the last slide is challenges which the seaweed face. So first we have the disease, which is ice, and epiphytes. And the solution to this currently we only have we shifted from the onshore to offshore planting and close monitoring. Also strong waves which affect the pegs and the ropes. So the seaweed ropes should be placed parallel with the water waves, which I just said earlier. Also sedimentations. That's why we're using the off-bottom method. Conflict between fishermen and seaweed farmers because of the area. So currently many of the countries in East Africa are using the spatial planning. I heard here in Kenya they've started it, and also us in Tanzania we've started the spatial planning in some of the MCAs. Other challenges other than that are the market issues, low technology and something like that. So for my side, I think I will welcome my colleague to continue.
Okay, good afternoon, everyone. I'll just speak from where my colleagues have stopped, and mainly I'll talk on the mariculture part. We have heard about seaweed and also about the fisheries. So I'll talk about the mariculture part. On Tuesday, we managed to go to Kibokoni, northern coast of Kenya, and we managed also to visit the self-help group by the name Umoja. And also, their group, it was established by the Community for Mangrove Conservation, and the group started with 11 members. And later on, the main focus was on the mangrove conservation. But since mangrove conservation was not maybe generate any income, the members were demotivated and started doing other things. But some few members still, they had interest on the conservation aspect. Then maybe they sit down and plan and decided to focus on fish pond despite limited challenges. Because they were interested of now doing the fish ponds, but they did not have maybe the knowledge on how to do the pond construction. So by that, in 2011, they received an acoustic funding through Dr. Mirera, Dr. Tunje, and Professor Mlewa, which helped them doing now to fulfill their interest. On the first trial was milkfish, later shifted to marine tilapia and mullet due to seed supply challenges. On milkfish, it was going good, but now a challenge on the seed supply, it was not that good. That's why they started on marine tilapia and mullet due to seed. Next slide, please. Okay, and then we were given task now to do the data collection and analyze on the same way we had on Umoja self-help group. Now the first, you can see the picture there. We are doing now some measurement of the milkfish, and here is the data which we have done. For milkfish, we managed to do 3 pieces. It was almost 12 p.m. The sun was too high. We were not able to remove all the fishes from the pond because of the high temperature. So we only managed to take 3 pieces of milkfish and do the standard length and total length of each pieces. And on marine tilapia, also we managed to take 2 pieces. Because of high temperature, we were not made to take all the pieces. So we measure 2 pieces, both standard length and total length. And also on the now data analysis, we as a group, we came with a K value to see like the growth ratio for both marine milkfish and marine tilapia, and average of each species. On that now we came with a graph for milkfish, comparing the mean length for each species and the K value for each same. So on the figure 12, you can see all of us, they are all growing good according to the length, the measurement we took. And also the mean length of both species were relatively close. Both milkfish and tilapia can perform well in community mariculture systems, according to the graph and the data analysis. Also the body condition factor, the tilapia showed a lower K value, but still within the healthy range, because it's between 1.2 to 1.6. Differences in K values reflect feeding efficiencies, environmental condition, and stocking density between the species. Now, also when we were interacting with them, we also managed to get the challenges and so the solution which the challenges were addressed. The first challenge was high mortality, which caused membership drop from 140 to 50 members. And the solution was in 2016, support from KCDP and enable pond expansion, which sorted that issue. And also the second challenge is it was on storage problems. And the solution was to harvest in small batches than harvesting the whole batch. And the challenge was seed supply remain limited, especially during the dry seasons. But a solution was research introduced marine tilapia for year-round seed availability. So recommendation we've given according to the data we've done and the analysis, the first recommendation is optimize feeding strategy, provide species-specific feeds to improve growth of performance, and also adopt feeding schedule that reduce competition and ensure uniform growth. So the second recommendation also on the milk fish specific, prioritize investment in milk fish farming due to strong growth, potential and good condition factor. And on tilapia aspect, we used tilapia as a reliable baseline species, since a lot of species maybe during dry season is not available, so they can use marine tilapia as a reliable source throughout the year. Up to there, say thank you.
Quest, yeah, that's the one. No, this is it. It's not the fisheries. What's the fisheries? Yeah. No, PDF.
So I know Fisheries has a second presentation. Is that correct? Do you all have a second presentation? Yes. Okay. So you have about 7 minutes to do that. Prior to, is there any questions for the first presentation from Fisheries? Your group new.
The videos.
Yes, they prepare for the kama sahi zingekuwa nacheza hiyo ina video sasa.
Okay, just hold on. Let me just bring a PPT.
My name is Professor Leila Abubakar. I'm the Vice Chancellor of Technical University of Mombasa. We're really happy to host our first coastal ocean and environment summer school in the West Indian Ocean. This is the first time we're having it in this region.
I am excited about this summer school and I hope our students are going to learn a lot from us. But also, it's also an opportunity for us to learn from the students.
My expectations for the week are to expand my interest in the fisheries sector, fisheries governance, as well as post-harvest that I can apply in my fieldwork as part of my master's research.
Oh yes. Ama namna gani? Si ni namna hiyo.
2025 Mombasa, Kenya. Burudika nasi.
Oh yes. There are no questions. Yeah?
It's ready. Ken, mwambie kuja jintroduce.
I'm Brani Murenya Mojong from Kenya.
Just come and do an introduction as they are loading the slide.
I am from Mauritius,
so that we can save time.
The group of climate change,
Physical and chemical oceanography group.
My group, it's a small scale and mariculture. So today, in the day 2, actually we had two
Thank you.
trips. First trip we went to the Umoja.
Yes, good afternoon, good evening, good morning for those following us online. My name is Asafari, and as part of our fieldwork, we were majorly looking into how we are going to transform science, policy, and innovation into now socio-economic development for the immediate resource users who are majorly now the local communities. And we were looking into how we are going to protect the ecosystems and also engaging in mariculture activities, and also how best now, once now they engage in mariculture, how do they control value addition and also post-harvest losses. So I would wish to welcome my group members, that is Grace, Jen, Najda, and also Agnes, to just run through the presentation and also share with you their findings. Thank you so much.
Good afternoon, everyone. I'm Grace, and I'll take you through the presentation that we have here, and that is how the presentation will run. That's the outline. We have the small-scale fisheries trophic level. That's what I'll take you through. We had mariculture, we had marine hatchery, and we finally do the fish value addition. Next slide. So, as my colleagues who presented earlier did, that is Justus, did the trophic levels. We had a data that was collected through CAS survey, and CAS stands for Catch Assessment Survey, and out of it we were given data from the Vanga BMU. Vanga is located in the southern coast of Kenya, and in this data we had species. We had 85 species, and these species we had to categorize them depending on what they feed. So we categorized them into 3. We had 3 categories. We had tertiary consumers, we had secondary consumers, and primary consumers. So out of the 85 which could not fit in one graph, we had to select 10 out of each trophic level, and then we could now, so that you could show what the categories as per the trophic levels. So we had composition, whereby the tertiary consumers had 39%, the secondary 41%, and the primary consumers at 20%. Next slide. So to connect between what these fish feed and where they are found, we had to do the graph showing what species are found in the coral reef environment. And from this graph, you can see that 77.1% were the secondary consumers in the coral reef. So the coral reef had the highest number of secondary consumers, whereby the pelagic group had the highest, being the tertiary consumers. So these are fish that are at the water column, you'll find them in that water column. They are the majority in the pelagic environment. Then the tertiary consumers feed higher than they feed on the secondary consumers. In the seagrass, you'll find more of the primary consumers because these will feed on the algae. So in the seagrass, you'll find more of algae together with the other organisms there. So most of it will be comprised of mainly the primary consumers. When you get to lagoons, you find also more of primary consumers. These are fish that feed lower. They are small in size, so most of them will be found in that habitat. So in a lagoon, you won't find the tertiary consumers. That is what mainly is presented here, and it's a true reflection of what a fishery ecosystem is and the different habitat what is comprised. I'll end at that and call the next presenter. Thank you.
Hello everyone, I'm Margaret Wamaitha. I'm going to present on the crab farming. So we visited a community in North Coast, that is in Kilifi County. We met a local community called Dabaso Creek Conservation Group. They were established in 2000. They have been doing crab fattening for almost around 25 years. And through the years, they have been using different techniques to do crab farming. And for the previous years, they started with traditional pen, then they went to bamboo, then they went to crates and all the techniques. They didn't last long, but for the moment, they are using the cages, as you can see here. So apart from crab fattening, they are also involved in ecotourism, and also they have a boardwalk. And through their restaurant, they have attracted more tourists. They do value addition. They have the crab samosas. And we went to collect data. We wanted to look at the length-weight relationship of the mud crab. They are mainly engaged. No, just go back. Okay. So for the data collection, we did the, please go back, please. Go back, please. Okay, this.
We collected a data of 10 samples where we classified them into 5 females and 5 males. With the female ones, we had both had positive allometric growth, and for the female ones, the growth was was not very strong. It was weak, with a positive correlation of about 0.255, which is about 20% of the growth. And this is because most of the female ones use most of their energy, or the energy for reproduction and for ovarian growth. For go to the next. The male ones were a bit much higher, with a positive growth of about 80%. And this is because much of their energy is used for muscle and the fattening. So that is the graph. Then we had another graph that was showing the combination of the two. From the results, you can see both had a positive growth, which was not very strong, lowering the male growth. Because of that, the female growth, you remember, was very low, and the male was a bit high. When you combine the two, it will be a bit lower than the male growth, but it was still positive. So that's all about the crabs. We go to mariculture.
So we got the privilege of visiting Namaret that is located in Shimoni, south coast of Kenya. So basically Namaret serves as a national hub for research, trainings, and more. So next slide. So I'll just take you briefly on what consists of the Namaret. So we have storage tanks that consist of 350,000 liters each. So basically this tank consists of seawater that is abstracted from the ocean. So we also have water treatment facilities that treat the water to avoid any pathogens, contamination. We also have an algae production unit. This is an essential unit because it provides feeds to the hatcheries, specifically the fish larvae. We also have the trial tanks. They normally undertake assessments before they could distribute the fish to the small-scale fish farmers. And we have presence of marine hatchery, whereby they culture prawns and fish, and also the presence of constructed wetland that treats water that is generated from the hatcheries. Next.
Good afternoon, everyone. So I'm going to take you through the fish value addition. We visited Chem-Free post-harvest lab, and we are able to do some practical hands-on experience. So here, the first process for value addition, first of all, value addition is improving the quality of a product to make it more profitable or to increase its market value. So we first get fish from the source, the ocean now, and then at the fish reception, we do a sensory test by observing the gills, smell, touch, and then we go to fish filtering reception. There at the fish filtering reception, we check the fish, its texture, and then at the chilled fish, we marinate the fish to improve its taste, and then we have fish ingredients for preparation to improve the taste too, and then we have fish marination. That's where we make things like fish fingers, and then we have buttering. We butter the fish using breadcrumbs or butter, and then we fry the fish, and then the products now, we were able to make fish burgers, and there we were taken through the processes in the lab by a data analyst. Yeah, and then at the fish value addition, we have products like fish samosas and sausages, and that's all. Thank you.
Next group, thank you very much for that presentation. Which is the next group online? Kindly confirm your presentation as you come to the podium.
Okay, hello everyone. Good evening. My name is Mark Matakili, and I'll be taking you through the physical and chemical oceanography. So we are here today to learn about what is physical and chemical oceanography. So scientists, there's a fun fact I had recently about scientists saying that currently the scientists know a lot of what is in the moon, and what is in the mass more than what they know about what is in the ocean. So that tells us that the ocean, the base at our ocean, there's a lot to be explored, but we haven't fully explored it. And that is, for me, to me, it's some kind of so interesting, because the ocean is just here, like living, if you want to access the ocean, it's just like some few meters from here. Unlike the Mars, which is requires some complex technologies to be able to reach there. So that one tells us that as scientists, we need to come up strongly and be able to identify what are the physical and the chemical operations that underlying the ocean that we need to explore. So just a quick summary about what physical and chemical oceanography means is that the physical oceanography helps us understand about how the ocean moves. We are talking about the tides, the currents, the heat waves, and whereby the chemical oceanography helps us understand about what the water in the ocean, what does it contain in terms of the nutrients, the gaseous components in it, such as the oxygen and the nitrous gases in the ocean. So through this week, we've been able to go to learn in this summer school. We've been able to learn about the whole of these concepts, thanks to our facilitators who have helped us capture these concepts that are really technical, to be able to understand them fully within this short period of time. So I'll invite my team to help to take us through the details of our concepts.
Thank you. So my name is Josephat. Good afternoon. Good evening. So my name is Josephat. I think I'll take you through the physical aspect of the physical oceanography. So when we're talking about physical oceanography, what are we talking about? Yeah, the physical bit of it. So it's the motion, it's the physical properties, the motion and energy distribution. So when we're talking about that, it's all about the seeing or focusing the ocean as a fluid ecosystem. So when you're looking at the fluid bit of it, what properties affect the fluid part of it? It could be the temperature, the salinity. So those are some of the properties we are talking about. When you're talking about the motion, ocean motion, we have currents, we have tides, we have waves. So all of these are some of the motions that we're talking about. Then we're talking about the energy processes. So the heat transfer. When we're talking about the ocean saturation, it's all about the heat transfer. You can also talk about the stratification, whereby the layering of the ocean. Sometimes we have a hot layer at the top, and then we have cold layer at the top. That's why we talk about the ocean upwelling. So those are some of the energy processes in the ocean. So basically, when we are studying the physical oceanography, we want to understand how do we focus about, or we use the ocean properties to predict about the climate change, shoreline erosion, or the marine aspect. The next group, the first group was talking about the different aspect of the fish. So how do we go about all those? So when we're talking about the processes, we need to understand. So when you walk along the shoreline, there are different features you see there on the shoreline. So what makes this feature? For example, the beach. What causes the beach to be there? In the patterns of the beach, what causes the patterns you see on the beach? So these are some of the processes that when the tides or the waves come to the shore, the sand that they deposit or the water that they bring with it, how does it come into play? So what we're saying, when we are studying the physical oceanography, we also need to connect it to the real life scenarios. Yeah. So when you're talking about the people going to fish, the fishermen, how do they know what time they are supposed to caught the fish? And the fishmonger, what time do they know they are supposed to go collect the fish? So knowing the tide chart helps the fishmonger to know what time the fishermen are coming back to the shore, so that they can be able to go and buy their fish. So these are some of the the different aspect or how we connect the physical oceanography to the community or the ecosystem bit of it. So when you want to, this one you can study it on a global scale, but also you can look at it on a localized scale. So for our case, we wanted to do on a localized scenario for this summer school so that we can be able to understand this. So my friend will take you through the next phase.
Okay, good afternoon. I'm Evans. I'll take you through our area of study. Our particular area of study was in Gazi, that is in the south coast. And as you all know, Gazi is, we have a substation, a Chemfreak substation. So our first place of visit, we went to Gazi substation. We were taken through what they do on a daily basis. We were taken through what my colleagues have explained on the physical oceanography. And in particular, they told us about a river that is coming upstream to the ocean. And there's a river called River Mkuruweni, and there's another one called Kidogoweni. We managed to be in the estuary of River Mkuruweni, and we had a physical observation of the ocean. We also managed to collect water samples for laboratory analysis. As you can see over here, this was a farmer who didn't want water to get into his farm. So there are two methods of controlling this water coming in from the ocean. We have the natural way. We can have mangroves to act as a barrier. We can have artificial barriers like this, and we can have also seawalls. I can tell you, after we left here, we went to Gazi. They've erected a wall. That's an example of an artificial barrier of getting water into the ocean. So, as you all know, it can't be practically possible for us to get into the ocean every day to collect data. And so, for scientists, we have to devise a mechanism of predicting these trends. So now, this aspect of modeling, numerical analysis. So my colleague Rodney will take through us the physical modeling, and we utilize now we utilize the softwares. Welcome.
Thank you, Evans, for the brief introduction. My name is Rodney, and I'm gonna show you how we take the physical processes and how we're gonna model them. So in the previous slide, you saw that we went to the field, but the data we collected at the field is not enough to draw enough conclusions, because we're there for 2 hours and then it's high tide. We leave, so we don't have enough information. So ocean modeling comes in and allows us to complement research activities by simulating various physical and geochemical processes that are happening in the ocean. For that, we're gonna use, maybe next slide. So this is us at the K-Lab in TUM, where we were working on the simulation models for the Western Indian Ocean and also for our site area. You see us some of the students. It's okay. You can go to the other slide. Next slide. So this is what we've gotten from the simulation. Ocean modeling allows us to map or understand the physical geochemical processes of a place by first having a 2D analysis or 2D representation of the area. If you see on the bottom on the map, this is a sea surface temperature, and you can see where there's labeled Lamu, the temperature is around 28 degrees. For our station in Mombasa, you see roughly the same temperature, but using the model, we produced this 2D representation. Next slide. So the ocean model is a very advanced software that allows not only the 2D representation of an area, but also the 3D dimension representation. So spatially, you see that's the whole EEZ of Kenya and some bits of Somalia and Tanzania. But the data you see on the right side is for a specific area in Gazi. So you see the temperature spiking mid-2023. So satellites move day and night. So the spikes you see is when it's night time, the satellite is moving. Or it's daytime, the state's moving. Or you can also do a 3D analysis of the air temperature. We can see like these are temperature plot. We have the 2D analysis and the 3D analysis. Yeah, next slide. So this is surface salinity for the same year for the 2023. Again, you can see the for those who are familiar, here there's some blue. So that's where the river water is coming in. So this is a salinity plot, and you can see it makes sense that where the river and the ocean are meeting, there's going to be dilution. So the salinity is going to be low. As you can see, as you move further away from the shoreline, yeah, it's okay. Maybe previous slide. As you move further away from the ocean, the salinity is increasing. Again, we did this using the ocean modeling, numerical modeling, and the next slide, as previously done, we can represent the 3D. So the first plot is two-dimensional, and then this is 3D, again, for a point in Gazi. Next slide. So what are all ocean models, and what can they tell us, and how can they help us? So models, these models, beyond this, whatever we've shown, beyond this analysis, these models are able to calculate or compute further outputs that are necessary for research, supporting field activities. So you go to the field, and then you want to, field activities are really expensive, especially when you're covering a large area. So ocean models and satellite data enable us to cover really large areas and also get outputs in a cost-effective manner. So these are some of the outputs, again, generated from the ocean model for a point outside or a point in Gazi. 3D, you see the depth, average current, you see the spikes, the trend, and also you can see here we have the surface elevation. Yeah, so next slide. So you can pause there. So I'm gonna introduce the next group. That's the chemical group, because we are physical and chemical. So what I can say is that the physical processes that happen in our ocean do directly affect the chemistry. So the physics is now affecting the chemistry. Now you want to see how the physics that we have just shown and how we have just studied, how it's affecting the chemistry in our region. Thank you.
Good afternoon, I'm Asipe. I'm here to introduce the chemical oceanography part of our presentation. Chemical oceanography is basically the study of chemistry of seawater and the processes that influence it. When we look at estuaries, we see how the biogeochemical processes happen, especially as the estuaries are the points where the fresh water from the rivers and the seawater from the ocean meet. And these create dynamics which lead to nutrient cycling and changes in parameters such as temperature and salinity. Why should we monitor estuaries? Estuaries play a crucial role as they are necessary grounds for many fish species, so it is important to monitor the parameters that are found in our estuaries, such as temperature, salinity, pH, and total suspended solids. We also had the opportunity to visit the Gazi mangrove forests and saw how the mangroves play a crucial role in mitigating some of the challenges in our shorelines, such as erosion. Mangroves, they trap the sediments which prevent erosion. They also trap dead substances such as leaves, detritus, which decompose to produce organic substances that are important for supporting life in the estuaries. And these organic substances include nitrogen and phosphorus. One of the activities that influence the mangrove include the digging of sand by the fishermen in search of the fishing baits, and this also plays a role in worsening the shoreline erosion. I'm going to hand over the next part, which is the methodology, to my colleague. Thank you.
Good afternoon. And as my colleague has said, she has talked about the parameters, and for our fieldwork, we looked at a few parameters. In the first picture, you'll see the device that we use to measure the temperature and pH. And just below that, you can see one of my colleagues measuring salinity using a refractometer. This was followed by water sampling from the estuary to the sea at 8 different points. So we took our samples to the lab, and we were able to derive the total suspended solids. This was done through a filtration system, so we were able to filter our water samples, and through the difference between the filter paper weights, we were able to derive the total suspended solids. We were unable to do the nutrient analysis with the spectrophotometer, but we were walked through it. And just for your information, a spectrophotometer is a device that uses the absorbency of light of the water sample to detect different nutrient compounds in our water samples. I will now invite my colleague to talk about our results.
Thank you for that, Steffi. Hello, everyone. I am Brian Nemurenye Mojong, and I will be taking you through the results and the interpretation. And the first one is the salinity. And from here, we can see we have estuary 1 to estuary 5. We have the harbor and we have the mangrove. And the mangrove and the harbor, they have high salinity, simply because this is an enclosed area in the harbor and the mangrove. And because of that, we have less freshwater input. And that results to have that place have a low solubility. And because of the low solubility compared to the other region, then the region has a high salinity. I will also go to the temperature. We can see that it is relatively equal, but for the mangrove it is relatively higher because of where we got the sample. You will see that this region has little pools that has been in the sun for a while, so when we get the sample, the temperature is likely to be higher. Next slide. Also, with the pH, you'll find that it's also all the same, but the pH varies because of the salinity variation. In the total solid suspension, you'll see that mangrove has the highest because because there is less activity, that is, there is less water movement around this region, and because of that, we are going to have the solid being suspended in this region, hence having the higher total solid suspension. I'll go to the next. And now we can see here by the graph the relationship between the salinity and the temperature. It's low, it's weak, and we can see it even from the graph. We can also see the relationship between the pH and the temperature is low because of the graph, and that you can also see through the R squared, because R squared equals to 0.011. So where the R squared is equals to a number that is near to 1, then that enables you to understand that the relationship is strong. So to the next step. The relationship between the salinity and the pH is very strong. As I've said, the R squared equals to 0.73, and that is near 1. The relationship between the salinity and the total solid suspension is also very weak, because the graph, you can see even from the graph, and also you can see that R squared equals to 0.11. So from this, I'm going to welcome my colleague.
Oh, thank you, Brian. My name is Derek Gitari, and please let's move on to the next slide. So for conclusion, key findings are is that estuary waters show dynamic changes in salinity, pH, temperature, and TSS, driven by tides, river input, and human activities, and this is evidenced in what we actually saw during our field visits. Field data and laboratory analysis also provide critical insights for the short term, but just as my previous colleague mentioned, for the long term, we need to look at modeling, and that is what gives us more data about the long term. Coastal ecosystems like mangroves, seagrass, coral reefs, fish are also highly sensitive to stratification, turbidity, and salt intrusion, therefore calling for more action from us to conserve these ecosystems. For the research implications, monitoring these parameters is vital for sustainable coastal resource management. And this, we were discussing it earlier on today, especially in our country, Kenya, with the blue economy sector coming up quite fast. This is something that is really important to focus on. Results also highlight the link between climate change, human activities, and ecosystem health. And when we went to Gazi Bay, it was actually evident as some areas where human activities had already taken place, it was evident that some mangroves were missing. There were some gaps in some areas where more human activities was taking place. And findings can also guide policymakers, who I believe some of you are here, conservation managers also here, and local communities in mitigating these impacts. So this calls for collaboration from all sectors, not just research scientists, but everyone who's in this area to come and collaborate together so that we can mitigate impacts of pollution. Next slide, please. For a way forward, to improve sampling frequency and spatial coverage, these data, as my previous colleagues mentioned, we have some data which we are modeling, which are data from even 30 years ago, but there's need to improve on this, and this is a call to action to all of us young professionals who most of us are here. This is something that we need to focus on. We also need to integrate socioeconomic data with physical and chemical oceanographic findings so that these can also help the communities improve their socioeconomic well-being, at least have some money in the pocket, and also improve their livelihoods. We also need to strengthen collaborations between research institutions and local stakeholders for long-term monitoring, and this is also a call for all of us here. The knowledge that we have maybe as research scientists or as young professionals is not enough, but if we bring it together with local knowledge and indigenous knowledge, this is going to push this sector to greater heights. Next slide, please. As the Chinese fundamental concept of yin yang says, in everything that has a good thing also has a bad thing. And everything that has a bad thing has a good thing. I'm not saying that these were bad things, but these were just shortcomings that maybe we can focus on, maybe to improve on the next training. And last slide, positive experiences. For me, it has been a nice opportunity to learn a lot. I was actually not so good. I was gray in matters numerical modeling, but now at least I have some knowledge of it. And also it's a nice experience having to sit in such a class with different people from different parts of the world. It actually shows us that the world is actually a small village. If you compare experiences from your counterparts from Seychelles, Mauritius, and everywhere else, you realize there are most of the things that we are doing actually cut across. Next slide. Maybe just for a parting shot, I'd like to ask all of you, let's take one big breath. That breath has partly been made possible by the ocean because it actually produces half of the oxygen that we breathe. So maybe next time when you go to the beach, when you go to take that dive by the beach, just pause and reflect as the waves hit your feet, or as you have that salty taste of water in your mouth. That is chemical and physical oceanography in motion. Thank you.
Thank you, thank you. More breaths to come. Thank you. We appreciate your presentation. Next group, kindly. Precisely, you kept time. Bravo. The next time, I hope you are going to emulate the same. Confirm your presentation as you come on stage.
Any questions for that group while we wait?
Any question as we wait? There's a question, huh?
Thank you very much. This has been a very, very exciting moment for me. When I arrived, the first presentation was on seaweeds, and there was the issue of value addition for the seaweeds. But what I did not see is the use of seaweeds for both feeds and also for fertilizers, because it has a lot of potassium. And since the war with Ukraine, nowadays people are trying to look at the potential of seaweeds for fertilizers. So that's supposed to be a value addition, but I didn't see it in the presentation. Then on the mariculture, I saw that nowadays they were moving towards marine tilapia. However, I didn't hear about the challenges, because, as you know, the tilapia also has these problems of stunted growth, and whether they have in those ponds, wherever they are doing the mariculture, whether they have they tried using the sex reversal methodology, or they are just growing them, haywardly kind of. So those are the two questions I would want to pose.
Answer the first question from the first group, and question number 2 from Fisheries.
So I would like to answer the first question about the seaweed. Actually, we know that seaweed is used for the manufacturing of fertilizer currently, but that is mostly done in the more developed country. We didn't experience that in Kenya, and that's why we didn't put it in the slides. But also we said in the suggestions that we need to improve our technology, as seaweed is the most abundant culture, which is basically a good income generator if we know how to use it and improve our technology. Thank you.
Okay, thank you for the question, which are very good questions, and also maybe through answering it will also address and also inform other people. So the first question is there any challenges which maybe the marine tilapia are going through? Yes, there are challenges, and the first challenge is the strength growth. The marine tilapia are facing the strength growth. Also, through the presentation, we can see the marine tilapia, the growth was minimum compared to a milkfish. And also, sex reversal, it is being done here in Kefri, and also where you are, the Umoja self-group members also are doing on the sex reversal. Maybe it's only did not appear on the PowerPoint, but still they are doing the sex reversal. In the next, I will put in consideration that I will put in the PowerPoint. Thank you.
just to add on something, because we were tackling on the mariculture. Why the main question we need to ask ourselves, why marine or salt tolerated tilapia? Because the main challenge we have in Kenya along the coastal region is one, the seed. We still collect seed from the wild. So that was a critical key intervention to at least ensure that farmers get seed throughout the season. Yeah. But more are still coming in terms of key interventions.
Hello everyone. I am Ashil and I'm going to present. So I'm Ashil and I'm going to present for the climate and physical processes. So let's say a brief introduction of what is climate change. So So climate change is a long-term shift in temperature and weather patterns, including global warming. So as we know, our ocean is being impacted by the increasing carbon dioxide and the greenhouse gases from the anthropogenic activities, which caused the changes in our water temperature and leading to the sea level rise, and also we are experiencing extreme weather conditions like extreme cyclone events. And as well, we have changes in diversity and abundance in marine species. So this consequence is a threat to the physical, economic, and our food security. So, yeah, okay. So we have two causes of climate change. The first one is natural, which is the solar variability, volcano activity, orbital changes, and national climate variability. And the second one, as I mentioned, is the human-induced factor like greenhouse gases, also deforestation, land use change, aerosol, and pollution. So the ocean also plays a vital role in regulating the Earth's climate. And from studies, we've shown that they absorb about 93% of the extra energy from the enhanced greenhouse gases, and but if we continue causing damage to our environment, or continue deforesting and increasing the greenhouse gases, we will end up our atmosphere will end up warming, and this can lead to the melting of ice caps, which cause sea level rise and have a significant impact on the shoreline for coastal erosion. So, So shoreline change is a shift in the position of the shoreline over time. And as I mentioned, the causes are the sea level rise, accretion, sedimentation, and the changes in wave pattern. So the mitigation and adaptation strategy is that we can reduce the emission of greenhouse gases. We can also reforest, like restoration program like mangroves or forests in general, and also using nature-based solution. So our field was, we went on two sites. The first one is Pirate Beach, and the second one is Gazi. So, okay. Yeah. Up. Now, move. Slide. Yeah. So, yes. So in Gazi Bay, we observe two species of mangrove, which is the Rhizophora mucronata, which is on the right side, and Soneratia alba on the left. So we can clearly see that on the left one we have the impact of erosion, like the sand has been washed away, and also on the right we can see some that the erosion has affected by there are a lot of pollution in the Rhizophyra muconata. So yeah, no, can we just up? Yeah. So yes. So we also observe some human activities, some impacts of human activities in the Gazi Bay, like on the first, on the top left, we can see some pollution, and we also saw that some ghost net fishing from the from the fishermen as well. And below it, we have a seawall which is protecting them, protecting the shoreline from erosion, but just behind the seawall, we had the mangroves. So one problem that from the seawall is that the mangrove needs like constant waves to bring nutrient or oxygen to the mangrove-associated species. So if we build this, build this seawall, these species won't have enough oxygen or nutrient, and this can lead to a decrease in those species. And we also note that the mangrove are important, is an important ground for nursery for these species, and it also increase the fish stock. So it can be an advantage for the fishermen, but if we don't let the species associated with the mangrove have their home or nursery ground, they won't be able to reproduce. So it's an effect. So yeah. And also on this side, you can see some impact of the coastal erosion. Yeah. So up. No. Down. Yeah. So this is the picture from the Pirate Beach. So in the center, we can see that there's a lot of glass bottom boat. So glass bottom boat is like promote tourism. So tourism can have impacts on our coastal ecosystem. Like if there are a lot more tourism in this tramping on the corals, they can weaken the corals. Also, the boat anchors from the boat anchors from the boats anchoring on the corals can weaken the physical structure and decrease its ability to dissipate our wave action. So it leads to more impact on the coast as well. So yeah, again, and also we can see some erosion. Like there has been a huge sand erosion on this side, and also we have several construction on the beach, like hotels and restaurants as well. Yeah, so can move up. Yeah, so data analysis. So we analyze the sea level rise of Mombasa. So we use data from the University of Hawaii Sea Level Center, and we use the R programming and Excel to generate the graph as well. So up. So yeah. So this is sea level rise from Mombasa from the 1986 to 2025. So here we can see between 1997 to 2000 we can see a huge drop in the sea level rise, and this is due to the 18.6 year lunar cycle, which causes either a drop or rise in sea level. So we postulate that this drop is connected to this cycle. And also we have it has predicted that if we don't take the necessary measures to protect our sea, the effect of the sea level rise will be increasing until 2076. Yeah, the black one. Yeah. So what can we do? So what can we do? We can use a nature-based solution implementation, and this is using nature-based instead of artificial reefs. So this plant is called beach morning glory. So it has various benefits of using the beach morning glory because it is adapted to harsh environment like dry, high temperature and salinity. So it is able to adapt to this kind of environment, and also they grows very fast. So and the root goes deep down enough to trap sand. So it is a sustainable solution to protect against coastal erosion. It is available naturally, and it is cheap. Yeah. So we also use a QGIS to map the shoreline changes, and the satellite image to extract shoreline annually, and we process. We've normalized different water index, and we import the shoreline into GIS, and we also use a digital shoreline analysis system to calculate the rates of shoreline change, and we analyze and map annual erosion and hotspot area. So this is a picture of a map showing the shoreline along the Mombasa Pirate Beach. So the line which is here, it is 2000, the year 2000, and you can see in the year 2000 where was the high water mark, and in 2021 the sea has been eroded from 2000 to 2021, and you can see that the sea is moving closer to the landward side. Yeah. So this is a 3-year annual shoreline changes. You can see that the beach is it's been eroded. Yeah. Okay. So recommendations. So we recommend to use a nature-based solution because it is a method that is proven in Mauritius, where I use a nature-based solution to combat several vulnerable beaches, and it has positive results. So we want to recommend that you use nature-based solution like the beach morning glory and expand the scope of restoration activity. Also, we can do a community-based approach, like training the locals and let them participate in any restoration programs that we are implementing. And also we need to have the policy and regulation control to develop and use cases along the shoreline, and foster regional and international collaboration. Yeah, so that's it. Thank you. Thank you.
Thank you very much for that presentation. Any reactions, questions as we wait for the next group? The next group. You can also follow us on social media. You can scan me from the screen. Like, share, and subscribe as usual. Kindly confirm your presentation. This is amazing. We have a whole group. Don't be scared, please. You are all on air. Don't worry. Thank you very much. Round of applause as they take the stage, please.
Good afternoon, everybody. Let's try that one more time. Good afternoon, everybody. My name is Rael Adhiambo, and we are Team Aquaconda. Thank you. And so we were looking at ecological survey and data management. I don't know if it's this. Yeah, okay. No. No.
Is it a PDF? No.
So just a second as we fix that. We had prepared for this.
Happy to host our first coastal ocean and environment summer school in the West Indian Ocean. This is the first time we're having it in this region.
I am excited about this summer school, and I hope our students are going to learn a lot from us. But also, it's also an opportunity for us to learn from the students.
My expectations for the week are to expand my interest in the fisheries sector, fisheries governance, as well as post-harvest that I can apply in my fieldwork as part of my master's research.
Welcome to Coes-Wio 2025 Mombasa, Kenya.
Francis Mutuku. I work at the Technical University of Mombasa, Kenya. I'm the lead instructor in the Marine Plastic and Pollution class. Interactive with the instructors. They asked all the questions. We and sometimes to cut off some of the questions because the learners were really active. And so far with the field up to now, it has been great. We are learning a new protocol for sampling microplastics along the beach at Diani. At this particular beach, we did not find a lot of plastics, so we will be moving to another beach where there is a lot of human activity and see if we will find a lot of the plastics we are looking for, and still continue learning about the sampling process.
I'm Jessica from Mauritius, but I am officially coming from the University of Rennes as a PhD student, and I'm participating in the Coes-Wio 2025. So my experience so far is that I really loved it. I'm loving it. I'm learning new things. We have professors like, instructors like Professor Motuko. We have Richmond, Walter, John, and they're really good at sharing their experience, and they are encouraging us to come forward with our views, our ideas, and I think that's really a good thing.
Okay, let's try this one last time. Yes. So, my name is Rael Adhiambo, and we are the team Aquaconda. And this whole week, we've been looking at data and ecological surveys and the importance of data in marine ecosystem management. Next slide, please. So I'm really happy that we are coming in after all the groups have presented. And what we've been talking about is balance. In marine ecosystems, it's all about balance, from the producers all the way to the decomposers. And across this balance, data is really important, as we have been told before, that data can be used to assess the status of the environment. It can be used to model future scenarios. And so for us this week, we decided to work with phytoplankton, because phytoplankton form the base of many marine all marine ecosystems, and they are also biological indicators of ecosystem health. They also reflect the changes in primary productivity and food web stability. And so we had two very amazing activities. The first one is we assessed the plankton community composition across mangrove and seagrass in Gazi Bay, Kenya. And we also learned some new, cool, awesome statistical softwares such as R and Python, and some things like Anaconda. So I want to introduce Marine to take us through the next stages.
Thank you, Rel, for this introduction, and good afternoon, everyone. So to answer these first questions, we decided to spend a whole day in the field to collect physical, chemical, and ecological parameters. So for that, early in the morning, we left the Technical University of Mombasa by bus to join Kwali, and there we had a first stop at Camp 3, where the professor introduced the region where we will do the sample. We then go to the first site, which is here in green. We call it the seagrass site, and the second one was from 30 minutes from the first one, and we call it mangrove sites. So the seagrass site has conditions that are closer to the sea, to open ocean conditions, while the second one, the mangrove site, has brackish conditions, which means that there is a mix between freshwater and seawater there. Yeah, and here you have two pictures for each side that give you an overview for both. So now I will give the floor to Amini Omar to have more details.
Thank you. Next slide, please. My role is to describe the physical-chemical parameter of these two sites that we take our samples. As Marine said, we have the seagrass sites and mangrove sites. As you can see here, we use the multi-parameter probes to measure the physical-chemical parameter that we take the temperature, salinity, pH, and dissolved oxygen. We also take a water sample for phosphate analysis. So as you can see here, our variables are not very different from those that they present from the physical and chemical oceanography. So the mangrove sites have higher temperature, same as the previous groups. And this is because the water there is more static and it was low tides compared to seagrass sites. And also the mangrove site has lower salinity, which is a reflection of more estuarine conditions. And as we note from the map there is a freshwater stream coming to the mangrove areas. And also the mangrove sites have higher organic matter content. I think you can see the picture here. Our leg was sunk in the muddy of the organic matter, and this is more because of the decomposition from the microbial activities. And for the seagrass sites, this higher salinity and lower temperature, because at that time the tide was coming at very high speeds, so there was a mix of water from open oceans or open sea. So that's why we think that may be the cause that lead to low temperatures. And the high salinity is because they took the salinity from the open water. There is no dilution there. So, Doreen, you are welcome to proceed.
I'm going to take you through sampling techniques. Next slide. For phytoplankton species, we used a 20 micron mesh size to sample, and we used a 20-liter bucket to draw water in the selected area. After sampling, we filtered in a sample bottle, and to preserve the sample, we used 3 to 4 drops of Lugol solution. In the laboratory, to achieve a homogeneous sample, we shake the sample and draw 1 mil of the subsample and transfer it to the counting chamber. In the counting chamber at the microscopy, we used an inverted microscope times 20 magnification to identify and tally the species. Once we identified and tallied the species, we recorded them in a data book. Thank you. I'm going to invite the Pasha. It's okay. Okay.
Yes. Thank you, Doreen. About sampling and analysis methods to obtain related and representative data, we began with numerous discussions and negotiations between the different groups. These exchanges allowed us to harmonize our methods, jointly define our analysis, and share our information. Once these data were gathered, we entered them into an Excel spreadsheet. This enabled us to organize, clean, and process them in a structured way. We then proceeded with the analysis to derive clear and actionable results. For our results, I invite Bipasha. Thank you.
Hello everyone. So next slide please. Yeah. So after the data analysis using the Excel, what we have observed is, firstly, we have seen that there has been two types of phytoplankton, which is the diatom and dinoflagellate. We have also seen that there has been a higher species richness of phytoplankton in the seagrass sites compared to the mangrove sites. Thirdly, we have observed that there has been more diatoms observed than the dinoflagellate. And lastly, if you see in the plankton composition, there's one diatom, which is the navicular species, which is much higher compared to the other phytoplankton. As well, we have observed a species, dinoflagellate, which is the Gambia discus one. This dinoflagellate is a potentially producing toxin, which can lead to diseases such as the ciguatera. Now, moving on to the next slide to discuss the result. Firstly, we can discuss that there has been lower phytoplankton as a result of the brackish condition in the mangrove sites and the light limitations. Also, there's a potential of explanation, which we have the high number of filter feeders in the mangrove sites. Secondly, the phytoplankton growth depends on numerous factors, such as the nutrient availability, light penetration, level of grazing, as well as the tidal action. So, we can conclude that in this study, more abundance and richness of phytoplankton was observed in the seagrass site as compared to the mangrove ecosystem. Thank you. I will now leave the floor to Yusuf. Rel. Sorry.
I'm not Yusuf, I'm Rael. Next slide, please. And so from the first activity that we did, these are the recommendations that we hope that the research communities along the coast will take up. And the first one is that it's important to note that our methodology was not rigid, and so it was for educational purposes, but still we got some really interesting results. And so we hope to see more data from Gazi Bay in a gradient from the brackish environment to the marine environment, of course with proper replicates, not like what we did because of time constraints. And then more studies also need to be undertaken to understand the nutrient, phytoplankton dynamics, the fluxes between brackish and marine ecosystems, and also larger spatio-temporal scale to include the wider Indian Ocean. And then we also need to have routine monitoring of potential toxin-producing phytoplankton because in our study we did identify one that had the potential to form, is toxin-producing and has the potential to form harmful algal blooms. Now, I would invite the next speaker to take us through the next activities that we did.
Thank you, Ray. Hello, everyone. As we wanted to do a further data management using a coding program, our instructor kindly shared with us data set to work on in R and in Python. So I'm gonna talk about what we have done with R. Here we have a table showing a data set that comes from Gazi with two sites, Eastern and Western Creek. An inventory of seagrass species was done there, along with some chemical and physical parameters. So we started to import this data set into R and to create some amazing graphs and to do some statistical tests. Could you move to the next slide, please? Yeah, thank you. Here, for example, we wanted to analyze data for the variable total biomass. First of all, we need to check if our data follows normal distribution and if the variances are homogeneous. So we check this with histogram and QQ plot, and then we confirm this with some statistical tests, such as Bartlett test and Shapiro test. This test gives us a p-value, and if a p-value is below 0.05, it means that the data does not meet the condition of normality and the homogeneous variances. So therefore, we have to conduct a non-parametric test, like a Kruskal test. This test compare the medians between two groups and tells us if there is a significant difference between them or not. And so here we have a p-value below 0.05, so it means that there is a significant difference between our two sites. For the next step, I will welcome my smart friend, Nkekali, to talk about another amazing thing that we can also do with R.
Thank you, Vero. Hi, everyone. I'm Nkekali, and just to summarize what has been said, R could be used to do data wrangling and visualization, as we've seen in the previous slides. Also, we've also seen from the previous speakers. And here I'd like to talk about how R could be used to calculate the mean and the standard deviation for your data. And the mean and standard deviation could be used to show the variability between the sites that you have, if it's either you're comparing between species, if it's either you're comparing between different sites, or any variables that you have, you could use R to do such analysis. And that is one of the tables that could be produced using R, and the graph we see here is a graph of mean variance that we calculated using the data, and from the plots there we could tell that the mixed meadows in the eastern had more variability in its data compared to the western, and you could also see how it varies from for different species. Also, in addition to that, R could be used for many other analysis that you could name of, let it be spatial and remote sensing analysis. It could be ecological modeling. It could be time series and population dynamics, you name it. So to be continued. This is some of the things that we did, but we could do so much more with R. I'd like to welcome Anthony for Python, yeah.
Thank you. My name is Anthony. And up to this moment, we've spoken of, we've dealt with data on a local scale, collected on a day. And sometimes, as the physical and chemical oceanography team commented, you need larger data sets to complement what you did on the field. You need data collected daily. And for such data, you might not have the capacity to go to the field on a day-to-day. So to access such data, satellites and Argo floats are instruments that are available to us. And these Argo floats and satellites, they collect data on very long time scale, years, months, and this data, because of the time scale, it's a lot. And to analyze this much data, that's where Python comes into play. So first, I've mentioned Argo floats, and I'd like to introduce you to what Argo floats are. On the left, that is an Argo float, the yellow figure. It's a robotic probe that is deployed by ships. And the Argo floats, they contain sensors that can be used to measure physical and biogeochemical parameters. The Argo floats work by, when they are deployed, they sink into the subsurface 0 to 4,000 meters depth, and they drift at that depth for a period of about 10 days, which can be programmed. Then they resurface to send back the data to the satellite so that the data can be retrieved for analysis. Next slide. On the left, you can see the number of Argo floats that are contained in the Indian Ocean. It's a huge, huge number, which means it's a huge, huge data set that is there, ready and available for us to analyze. For our team, we took the Argo float on the right. That's the one we chose. And the Argo float, and that figure shows the Argo float trajectory in red. And as you can see, the Argo float has been drifting along the East African coast, along Tanzania, Kenya, and Somalia. And from that data, from the Argo float, we were able to collect data that has been collected since January 2023 till yesterday. And the data we collected includes light, nitrate, chlorophyll, temperature, dissolved oxygen, and particulate matter. So from that Argo float, the data, we use Python to analyze the data and create the charts. Next slide. From the data we get from the Argo float, we can be able to create such charts from which we can understand the physical and chemical processes that are undergoing under the in our oceans. On the left above, the first thing we can do is create a line plot to understand the trend through time of a given parameter. On the left in blue we have oxygen, and through time we can see there are variations according to the months, which is shows a seasonal variation between the wet season and the dry season. In the right we can see in red, it's a line plot showing the trend of temperature. On the x-axis it's time, on the y-axis it's the temperature, which also shows seasonal variation through seasonal variation up and down. Below, these are section plots. These section plots, they show the variation or the stratification of the variable according to depth. On the left, in green, you can see the section plot of oxygen concentration plotted from the Argo float that shows a stratification of a region, a layer in the upper 0 to 100 meters that is highly rich in oxygen, which it could indicate the phytoplankton density, phytoplanktons, which they take up the CO2 from the water and they release that oxygen. In the middle, the graph shows the temperature section plot, also showing the layer 0 to 100 meters being warmer than the layer below it, showing further stratification of this layer, and that warmth could support the presence of the phytoplankton. Our last graph here, it's the chlorophyll variation through depth and time, showing seasonal variation from hot to dry seasons, showing different concentrations of chlorophyll in our oceans. And now I will introduce Helio to explain to us satellite data. Yeah.
Hi everyone. I'm Elio, and as spoken previously, we can get our data from the field, or we can also get our data from Argo floats or also from satellites, where we use the data from the NASA website, which is basically getting data from the satellite. So from there, we were able to see a trend from the last 33 years throughout the world. So from there, we can also get the same data from the Argo float, has salinity, chlorophyll, light attenuation, carbon, and surface temperature and height. So with those data, we can see what have been happening during the previous years and maybe project what we want to see in the future. So from here, we can see on the left side the spatial distribution of chlorophyll in the spring season. So from there, we can have a daily, weekly, monthly, and yearly data, and also seasonally. And here we have chosen the spring season, where we can see the distribution of chlorophyll throughout the globe. And here we have highlighted the zone where we are now, which is Kenya. So you can see from this part showing the coastal of Kenya, and here we can see the Madagascar. So it highlights us that even in the spring season, we're still having some primary production throughout this coastal zone in the Western Ocean, Indian Ocean. So with that, we started trying to plot graphs and getting data from the, to work with that in the Python from the previous week. So for now, we are able to compile those graphs and see what have been happening during the years. So it's a pleasure to be able to work with that and analyze those data and see what is the behavior in our ocean. So with that, I want to say thanks for the organization and also for the instructors that have been guiding us to achieve this goal. Thanks.
Okay, mine is to conclude the presentation. So please, the next slide. Yeah, so as the data team, we gave ourselves a name, the Aqua Conda team. So it was really interesting to have started this from last week, just trying to learn RStudio, downloading the packages, using Python to just come to this week, go to the field, collect data. We did all that and went to the lab, but it was more interesting to get to download data from NASA and from the Argo floats, decode it, and then interpret it the way we have. So what we got from that is that there is so much more that can be done using these data resources, and they are great for statistical analysis and also to use to study trends and climatology. So for that, we really appreciate the team effort of Aquaconda. We also appreciate our instructors. They've been really instrumental since last week, and we'd like to say thank you. But we'd also like to say to be continued, because what we've learned, we need to practice more and more so that you can decode more data that is being analyzed daily. So thank you.
Wow, that was pretty good. I love the teamwork. Team Aqua. Thank you very much. Usiambie mtu, only for the legends. Any questions, reactions? 25 minutes. Oh, we're having the last group. Wow, 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 wow. As they take the stage, the last group.
Confirm the presentation. Okay. Marine plastics. Hello. Marine plastics. Yeah. So maintain until I say next. Okay. Hello, ladies and gentlemen. Good afternoon. It's evening. Okay. Good evening once more. My name is Kevin Ochieng, and I'm here representing Team Marine Pollution and Plastics. So allow me to begin with a random question. So how many plastics have you used in the past 1 month? And out of that, maybe how many of them have you been involved in recycling? Or let me get down to a lower one. How many have you maybe reused? I know the number is quite incomparable, and that exactly where the problem is, that this leads to excess plastic waste that lies around the environment due to disparity between the recycling rate and the dumping rate. To be honest, our consumption is quite high than what we really recycle, and that leads to excess plastic waste that get washed away into the ocean. So once these plastics are in the ocean, they choke our marine life, they confuse them as foods, and of course, they entangle these sea creatures, limiting their movement to search for food. So plastics, once are in the ocean, they do disintegrate into smaller pieces, and of course, we categorize them based on the diameter. Please, next slide. So at the very base, we have the nanoplastics, which is 1 micrometer, then followed by microplastic, which is 5 millimeters. Then mesoplastic follows with a 5 centimeter in diameter. And lastly, we have the macroplastic, which is 50 centimeters. Next slide, please. So we do categorize these plastics into 7 categories. The most common categories are, we do have the PET, that is polyethylene tetraphthalate, which is mostly the water bottles we do have here. Then we have the high density polyethylene, mostly found in shampoo bottles. We do have them in cooking oil, vegetable cooking oil. We do have polyvinyl chloride, the PVC, mostly found in cleaning products. We have the low density polyethylene found in plastic bags, these bread bags. We do have polypropylene, the yogurt stuffs. Then we have polyestyrene, the takeaway, the one we used while going to the field. And we do have other categories as well. So that's all from my end. Let me invite my next colleague to take you through the next slides.
Good afternoon. Okay, my name is Mamlo, and I'll be proceeding with, we all understand that plastic is a problem, but did you ask yourself, like, how many years does each item we produce every day takes to decompose? So we have numbers here. We have shown for each item that we produce every day or we use every day, from organic waste to non-organic waste. We have banana peels that take almost 4 weeks to decompose. And we have papers up to the t-shirt that we are wearing right now. So you can see. Please proceed. Okay, so as my fellow have highlighted the introduction of the plastic and marine pollution, I will take you through the materials and the methodologies that we use to to survey plastics. One of the things I want to tell you, plastic is for everyone. So we all here are responsible for plastic and pollution. To facilitate our survey, we used the collect protocol. This is internationally standardized and a systematic protocol for marine litter surveys. And specifically, we use this to collect or to identify the litter abundance and the distribution. And this has been used across all African countries along the coast. So for us, we had to begin with site selection or site identification. Here we selected to visit Diani Beach, 2 of the location along the Diani Beach, one being Mwabungo and another one being Diani Beach or Atiukunda. So our team were divided into 5 groups, and each group were assigned a station within a distance of 50 meters. And each group had to collect sample within a 10-meter radius. So we had almost 3 locations for our group. Please proceed. So the samples were collected. Our aim was to collect macroliter, mesoliter, and microliter. But unfortunately enough, the location that we are selected was the beachfront of the hotels. So most of those locations are being cleaned each and every day. So we are not able to collect macroliter. We had a chance to collect meso and microliter. So what we did was each of the group were provided with sieving tools, the wire mesh with about 2.5 millimeter space. So we collected the particles within each radius, and all were sieved. Those particles above the mesh or the sieving tools were collected and recorded, but those which were able to penetrate were packed into the foil for further analysis, and were taken to the laboratory. Proceed, please. Oh. Come back. Okay. Apart from collecting meso and microliter, we had a chance to collect NADOs. Is here anyone knows about NADOs? Can I see your hands, please? Okay, my brother there. So NADOs are a very smaller plastic pellets or particles, and they range between 2 centimeters to 5 centimeters, and they are the material used to make plastics, and most of the industries use them to make plastic products, and the leakage comes from the industries. So to understand this, we had a chance to distribute ourselves into 3 teams, and each within 50 meters to collect NADOs. They are very small particles, so it need carefully consideration to pick them. So we are able to collect the NADOs and pack them into a glass container and taken to the laboratory for further analysis. So for microplastic, I would like to welcome my colleague to proceed with it. Thank you so much.
Good evening. My name is Maureen. I'll take over from my colleague. He mentioned that we collected macroplastics and microplastics. No, we collected sediments in the field. Now we had to take it to the lab to determine microplastics, because microplastics cannot be seen by our naked eyes. That means we need an extraction method in the lab. So with our sample, we were able to prepare sodium chloride. Sodium chloride, we use it so that you are able to separate the sediments from the microplastics from the sediment. So there are different methods of separating microplastics in the lab, depending on what you have, and also depending on what the type of polymer that you want to extract. So for us, we were able to use sodium chloride because it's dense. Because it's denser, that means that once you dissolve the sample that you collect in the field, it is going to sink and allow the microplastics to float in that liquid that you make. And then you will give it time to settle. So you will give it like 1 to 2 minutes, and then you let it settle. The sediments will sink, and then the microplastics will float. Now, and then after you have your how do I say it? After you have your liquid floating and the sediment sinking, you collect about 100 to 200 the top layer, and then you use a vacuum filtration to filter, to vacuum and remove the microplastics, and then it will go to the, you'll take the filter that you passed, you'll take it to an oven at 40 degrees Celsius for around 3 minutes. After that, you will have to use a microscope so that you are able to determine the different types of microscope. Next slide. So these are just pictures showing how we are trying to see the different types of microscopes, the different types of microplastics using an electron microscope, and then my colleagues will be able to show you the different type of microplastic that we found in the lab. Thank you.
So good evening, everyone, and let's move directly to the results. So first, during our data collection, so yeah, we take our sieve and all the particles, that is our marine debris, and including our plastic, we collect all and we note it into different categories. So you can see here, we have different categories: stick, plastic fragment, shell, etc., organic matter like seaweed. Also, we are dealing with microplastic or plastic. We also tend to collect seaweed or any organic matter for further analysis, or we can have any exploration. So here we have a representation in our first site, that is our Diana Beach. So we can see we had a lot of seaweed, obvious because it's the sea. So here we also found some plastic fragment, although it was a big tin, but that doesn't mean we will not have microplastic. So we will see if we had or not. So next slide. So now our result. Fortunately, we got microplastic, but unfortunately, it's a good and bad news. So what do we do with the microplastic? So we see our lab procedure. It's a long-lasting procedure for the extraction of microplastic. Now we have our filter paper. We took our electron microscope to view it and count individual plastic in our filter paper. We took its size, and here we had mainly 3 types of microplastic. We had fragment, fiber, and filament. So we can see the first bar chart. What we are trying to show is a comparison between 2 sites in Diana Beach. So we had 2 spots. So you have to keep in mind the first spot is clean and is less affected by human activity. So compared to the other side. So the first site name is, if I'm not wrong, Boana Resort, versus the second one is Trent Wind. So it is more affected by human activity. So we can see the site that is affected by human activity, we tend to have more types of microplastic. We can see it's overcome in terms of fragment, fiber, and filament. So the second one, we go deeper into the ocean, not the ocean, but the plastic. Yeah. So now we took our fragment and we classified in terms of color. So this advantage of having this bar chart is we can find 2 pieces of information. First, we did a comparison in color between the first and second site, and also we can do within the first site. So we can see that within the first site, we had red fragment dominate, but it is absent in the first site. So the second site, we had purple fragment dominate. So we move to next slide. So now, fiber turn. So we did the same principle. We had, so what we can see, what we can notice here, we had a trend between both sides. We had a dominance of blue fiber. This can be a possible explanation is maybe fishing line. So that's why you have dominant blue fibers. So now we already talked about needles. So in terms more easily, a needle is a small plastic a small plastic bin, like we say it's an industrial pellet. So within a range between 1 or 2 hours, we were able to collect 292 pellets that were found, that is needle. And we classified into color, and industrially it is manufactured white, so we tend to find more there. So next slide. So next. So what we can see here, it's a filter paper that we took a photo. We can see like the red dot is representing the fiber. It's a color, it's blue fiber. It's not quite visible, but you can trust me. So now one thing I want to add on is when we are dealing with microplastic, it is not just the physical properties that we should analyze. We should go further into the chemical composition. But unfortunately, we cannot do that here due to maintenance technical effect. No, it's maintenance issue. Yeah. So yeah, the advantage of doing an FTIR, that is a polymer characterization, is to know whether if you have any doubt whether it is a plastic or not a plastic and organic material, so the FTIR can quickly determine that. And the second advantage is that we can classify it into polymer type, like different plastic material. We had PVC, we talked before. We had PVC, PE, PE, HDPE or PE. We can see which one is abundant. So we move to the next person.
Thank you, Chetan. Good evening, everyone. I'm Jessica, and I'm going to continue with our interpretation of the results which were presented by Chetan. So what we can say is that more microplastics were present in the sediment samples collected from Mwabungo Beach than in Diani Beach. And the possible reasons are that there are several factors combined, such as the status of the beach as a premier tourist destination that attracts significant investment in beach upkeep and management. For instance, when we were on fieldwork, we could see that there were signs prohibiting the use of plastics on the beach, and we also saw volunteers cleaning the beach. And for example, we have the Diani Turtle Watch there, and they regularly clean the beach. During our community survey, we also found out that the local community in Diani are also involved in cleaning the beach. On the other side, during our visit to Mwabungo Beach, we could observe more human activity, which may explain the higher level of pollution. And to explain the colored microplastics that were found predominantly, blue, red, brown on both beaches, we would say that it is microplastics originating from anthropogenic sources such as plastic packaging materials, bottle caps, fishing equipment, and consumer products. And finally, the presence of plastic nodules on Mwabungo Beach suggests that the place is not only contaminated with degraded plastic materials, but also with primary microplastics that are produced by the industry. So my colleague here, Freeman, will continue with our results for the community survey. Thank you.
Thank you very much. As we've heard, the situation that we've experienced, we also wanted to know the communities living in these areas, like how are they reacting to this situation? What are the current initiatives in place, which we would like to understand so that we could understand how well we're going to combat the situation of plastic pollution. So the demographic age, we saw that there's a big number of youth, and also the knowledge is most of the people that we talk to, the knowledge is well. There's a high increase of knowledge in terms of the current situation of marine pollution. Like, people understand like what is happening because some of them started experiencing these impacts. But also the concerns, there's been a raising concern amongst people, the situation in this marine pollution. Because in these two beach sites where we went, visibly, you could see the beach is very clean, but in reality, these data that we took shows that there is high quantity of these microplastics in the soil. So I think in the next slide. So as I said, the survey captured a very high number of youth, and this is because most of these people, as you compare in these two beaches, one of them had very little human interaction, so even the results show that the pollution was not high. But the other one is it's an open beach. There was so many people doing some tourist activities and everything, so that's why we had a high number of youth. But also the majority they're feeling well informed to the effective prior exposure of information on plastic pollution, perhaps through media, community programs, and their personal experience. We also saw a small portion of people who are non-enlightened, but they highlight knowledge gaps that could be addressed via targets. We also saw there is individual initiatives by the small marine, these are local marine organizations in the community level. They're called beach management units, of which they were very active. We could see them having individual initiatives of trying to provide education and also participate in the beach cleanups. But also, this self-assessment is subjective and might overestimate actual understanding, but we suggest a foundation for building more advanced awareness, potentially leading to a greater community action against this pollution. But also, lastly, the high level of concern reflects a strong recognition of plastic pollution as a pressing issue. Various people also gave testimonies that some of these key marine organisms that also provide income generation to these people, especially to people in the tourist sector, they've experienced the impact. As we know, there are some sea turtles. They like consuming these jellyfish, but when they see these plastic bags, they mistake the jellyfish as the plastic bags. So some of them, they end up in the shoreline dead. And some of the other organisms, they, when dissected, you find there are some plastics which they are consumed. So most people understand how vital it is to have this to combat this problem of marine plastic pollution, but also because the impacts are already experienced, although at a high level, but it's growing due to the economic activities in this area. So leveraging this overall might encourage participation in cleanup efforts, but also through sustained action. It requires a converted consent into behavior change. So I would like to welcome my fellow colleague to also explain about the initiatives, various initiatives with other organizations which help to combat this issue of pollution, especially the organic waste. Welcome.
Thank you so much. Move next, please. So we also had the privilege of visiting ERI Kenya. ERI stands for Health and Environmental Research Institute. It's located in Diani, that is southern coast. And at ERI Kenya, they use black soldier fly, which is BSF, to convert organic waste into usable or valuable fertilizer and animal feed. So as part of marine pollution, we know that along the Diani coastline, there are many hotels there. So if we can convert the huge amount of organic waste from food that is generated by the hotels, we can solve the issue of pollution, that is marine pollution, by other contaminants apart from plastics, which was what the work focused in our group. At the site visit, we were taken around what goes on once the waste arrives at the BSF facility, and the BSF is able to convert the waste into organic manure and fertilizer. And we were told that the value of the organic manure from the organic fertilizer from the BSF is slightly cheaper compared to the synthetic fertilizer. So by utilizing the beneficial factors of the BSF, we can have fertilizer and then also contribute to food security. Another output from BSF in decomposing the food waste is generation of feed for poultry. We know poultry farming is very expensive in terms of feeding, and if you can use percentage of the food from the BSF, which is organically generated, we can reduce the costs and also have economic impact on the communities. So this is what we encourage others, different countries and also regions to adopt. It's something that can be used in management of waste and waste reduction. And move next, please. So so that is one of the pictures we took from the facility. Move next. So in summary, what can we conclude from the studies that although the beaches at Diani and Mabugo are clean, there were detectable amounts of plastics in certain low levels, but now that calls for need to further analysis to identify what could be the possible composition of those plastics. And also there's also need to have an action where we raise awareness on microplastic pollution, both from general pollution of plastics and also create awareness that everybody becomes a change maker in the fight against marine pollution and plastics. And there is this quote that says that plastics are persistent and they live long. But we humans, we generate them and the nature cannot digest them. So as other group talked about nature-based solution, there is no nature-based solution already reported for plastic degradation. So it's our effort to prevent usage of plastics if possible and adopt more biodegradable options. I now welcome my colleague to give final summary.
Thank you so much, my group members. Thank you, the members of FLOW. One thing to close with, we are all here not safe from plastic. And every one of us is responsible to fight against single-use plastic products. We here given today the reusable or refillable water bottles. Please, take use of that. Please keep it. From now on, take a pledge to stop using single-use products. Thank you so much, our host, for providing us with such a valuable resource. And we, as a marine pollution and a plastic group, we have one word to you as we go. If I say plastic, you all have to say plastic punch. Are you ready? Are you ready? Can we stand up, please? I know you guys are tired. So we all here are born with energy. So we have to use that energy to close this session. Please get yourself warmed up. If I say plastic, we all say plastic punch. Try it, plastic. I say plastic, you say plastic punch. I want to see this building smiling from our voice. So 1, 2, 3. Plastic! 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 One more! Thank you so much.
Wow, wow, wow. Bravo, bravo, bravo. Plastic! Thank you. Thank you very much. That was awesome. I think we have come to the end of the presentations. Or is there another group? Are you sure? If there is no any other group, maybe I can welcome our facilitators if they have 1 or 2 items to share before we close this session. Otherwise, thank you very much for your courtesy and cooperation. It was a nice session. all over. Welcome, Dr. J.
Thank you all for your patience and understanding. We recognize that the schedule has been pushed back moderately. So what we're going to do is be extremely efficient together. What that looks like is instructors, I need you to come down so you can get on the first bus back, refresh, so we can get you all ready for the ceremony. And then we'll start loading the bus back in groups. It will take time, so please take selfies, get contact information, decide what you're going to do next to work together. Also, if you have changed your project track since we assigned it to you, that is essential for your certificate that we are going to give you. Gabriel, can you please raise your hand? Gabriel's in the back. Please go to Gabriel in the back and let him know if you have changed your project track so that we can update our records and get you the appropriate certificate. What questions do you all have? I would like to see the best dancing that you have done all week tonight. Don't be shy. We're about to get ready to party. Okay, wonderful. Oh, one other thing, certificates. There's going to be an assessment that I will send out, or Gabriel will send out to everyone. To receive your certificate, you have 1 week to complete the assessment. Everyone must complete the assessment. It is based on your project group. It is something that you will be able to complete as long as you are engaged and involved this week. So look out for that assessment. Once that has been processed, we will be getting out all of the certificates. So we'll have updates around that, but you will have to complete that assessment and that will be shared out to you. Lastly, how many of you need transportation to the airport? Raise your hand. Wonderful. We want to get you there. So please make sure you have registered your transportation information in the link that was shared in the WhatsApp. Miriam has shared it multiple times, so we're going to ask that you have completed the transportation information promptly by 6:30 p.m. tonight so that we can start to organize our transportation efforts for tomorrow. Thank you all. Instructors to the front, please. Thank you.